This is problem number 3 from section 2.4. It says the retail flat rate in dollars for first-class mail weighing up to 5 ounces could be computed by the piecewise constant function p, where x is the number of ounces. So these are the number of ounces here, and this is the price. Evaluate p of 2.8 and p of 5. So let's go to part A. They want us to say what is p of 2.8, meaning with an input of 2.8 ounces, what's the price? Well, if we go to where 2.8 would lie, it's not between 1 and 2, it's between 2 and 3. So 2.8 is between 2 and 3. That means the price is $1.36. So we'll write $1.36 here for a price. And then we'll look at p of 5, which is 5 ounces. Now remember, this says less than or equal to 5, so this is good. That's in this range here, 4 to 5, with it can be equal to 5. You can see that that's $1.82. Part B, they want us to go ahead and sketch a graph of P. What is the domain of P? So let's go ahead and sketch the graph. We're going to make kind of a rough graph. I think you can do this on your graphing calculator as well, but we'll just go ahead and make a rough graph of it by hand. So this is going to be, we're going to start at 0.9 actually. So I'm going to go ahead and mark this. We'll just go, let's go 0.5, 1, 1.5, and 2. And then from 0 to 1, so 1, 2, 3, 4, 5. From 0 to 1, we're at 90 cents. So we're going to go ahead and say, and at 0, it's not defined. If you notice that, right? It's not defined. It says x is greater than 0. But it is defined at 1. So this is going to be an open dot. I know it doesn't look open to right here. From 1 to 2, it's going to be $1.13. Again, open dot here. Close dot here. $1.36 from 2 to 3, so that's right here to here. $1.59, so that's right here, there. And finally, we're close to almost $2. We'll go open dot here. So you can see that we have like a stair-step function here, and that we have jump discontinuities in between each of these. Now, if you use a graphing calculator, obviously you'll get this to look a lot better, and this is very rough. All right, but we're just kind of just taking a look at what does this graph look like, just estimating. What is the domain of P? Well, the domain of P is what are the input values? Well, you can input anything from 0 ounces to 5 ounces, but you can't actually equal 0 ounces. So 0 ounces, I mean, you wouldn't be shipping anything, right? There's something, everything weighs something. So we're going to say from 0 to 5 ounces, but 5 ounces is included. So our domain goes from 0 to 5. Although it jumps, it's always defined at those integer numbers. Now part C. Where is P discontinuous on its domain? So it's discontinuous every time it jumps. So it's discontinuous at 1, at 2, at 3, and at 4. And we can see that here, 1, 2, 3, and 4. So we're going to say jump discontinuities at x equal 1, 2, 3, 4. And those jumps are when we're going from basically ounces between 0 and 1 to 1 and 2 to 2 and 3. It's basically at those integer marks that we start to switch over to a different price value.